Reading and Writing in Mathematics. This is Kitty Rutherford, a mathematics consultant for the North Carolina Department of Public Instruction. In this session, we want to talk about how reading, writing, and mathematics comes together in an effective lesson to improve students' mathematical thinking. Explore strategies that actively engage students in meaningful learning that makes a difference in students' mathematics achievement. I've received many phone calls and emails over the years asking how reading and writing in mathematics should look like. So hopefully throughout this PowerPoint, you will have some ideas how to integrate these content areas. I wanted to share throughout the PowerPoint as well different resources and research that you may use to support and encourage people to think about how reading, writing, and mathematics goes together. This resource, Principles and Standards for School of Mathematics, again talks about the importance and the benefits of this. It's a quote here that says, "They communicate to learn mathematics and they learn to communicate mathematically," which helps students be successful in math class. We're going to focus first on writing in mathematics. So here we know we have the North Carolina writing standards, and in those it talks about writing across the curriculum and the different types of writing. So we hope to hit upon these throughout this presentation. First, want to share with you about writing to learn mathematics, and we can see how it is in mathematics all the way up to higher level. So it says, contrary to popular belief, mathematicians must write and must write well. Statisticians write coherent reports. Math educators express themselves in the discipline, and pure mathematicians communicate complex yet precise ideas. So math and reading and writing go hand in hand, helping kids understand that reading and writing is not something different, that they can be intertwined and be intertwined successfully. Here's an example about writing to learn in mathematics. Here they give an example of how you could write a letter to a classmate who did not attend class and help them understand what they learned, or reflect on your participation in class, and they even have some starters there. Another one is reflecting on what you did in a course. So this can be done in upper level mathematics as well as lower level. So just some nice examples from this resource. Another resource is the Marilyn Burns Writing in Math class. She talks about the process of writing requires gathering, organizing, and clarifying thoughts. It demands finding out what you know and don't know. It calls on thinking clearly. So this is talking about the writing process. So think about the math process. It says in mathematics, we also gather, organize, and clarify our thoughts and find out what you know and what you don't know. And to do that, you must think through that process. Although the final representation of the mathematical pursuit looks very different from the final product of a writing effort, the mental journey at its base is the same, making sense of an idea and presenting it effectively. So I think sometimes, especially in elementary, we think of reading and writing very differently than we think of mathematics. We think of mathematics as being more procedural type, where kids just do a procedure and they don't think about it and know and understand it to the depth at which they should. So they should know it deeply so that they can write about it. And writing helps build that. A nice quote from Marilyn Burns. It says, students' early school experience with learning mathematics are critical for forming their basic attitudes and understandings. During the elementary grades, they must develop an appreciation for and interest in mathematics. Learn to think and reason mathematically and be prepared to face new mathematical challenges. Another article, which you could click at the bottom to pull up, it talks about, again, innovative teachers who make writing an invaluable part of their instruction. Kids need to understand and see how they go hand in hand. helping kids to organize, clarify, and reflect on their ideas. And mixing of writing activities also gives teachers a broader insight to students' mathematical experiences. Writing strategies. In a writing class, Marilyn Burns offers these 9 suggestions. And again, the link is provided for you at the bottom. Feel free to stop, discuss, pause, pull up the article. So the 9 listed here talk with students about the purpose, establish your audience, use students writing in the classroom instruction. Again, helping us wrap our minds around how math and writing should look or could look, and strategies we could use. This is an example of a task that I used in my classroom. It's called a class party. It comes from Kendall Hunt. And in this, students had to write how they would solve this problem. And I've given some examples of some student work, which are hilarious. Suppose there are 25 students in your class and you have $10 for a class party. Tell how you would spend the money and explain why you would spend it that way. Use as much of the $10 as you can, but do not spend more than 10. There's no tax. Be sure your plan works for a class of 25 students. And again, you can tweak and modify this prompt and think about how you'd like to use it. So let's look at some examples. This is the table. Again, you could tweak or modify it. This is the items that we use for this. We have lemonade, paper cups, ice cream bars, oatmeal cookies, bag of popcorn, and napkins. And you can see the cost and the amount at which each of those would be per cost. So here's an example. You can see the student has thought through the process, has written about her thinking. As they write, they clarify their thinking. Feel free to pause this, stop, take some time, and talk about it. It goes on to say everybody needs lemonade. She's calculated it. Then she says that's more than half of my $10. Maybe everybody can get half a serving. So she realizes when she's used $7.50 of $10, see, she has an understanding of the amount and realizes that doesn't provide her with much if she spends $7.50. So she decides to do half a serving. I mean, think about the mathematical thinking going on here. So then she talks about, now I only need 2 pitchers. So she goes on, she adds that up. Then she says, look at the napkins. Let's buy some napkins. And she adds and calculates that. Now she finds out her total, finds out how much she has left, and then decides to buy popcorn. So as you take a few minutes and look through this as a teacher helps us know that she can clarify her thinking, she understands the mathematics, and this in my mind lets me know that she understands the concept of addition, multiplication, division, and how to use it and apply it. Here's another example of another student. I need lemonade, and since there are only 10 servings in a pitcher, I need 3 pitchers. So, and there he is, he's adding versus multiplying. So what does that let me know as a teacher? I have $2.50 left to spend. Now I need paper cups, so he purchases the paper cups. And this is the part I thought was hilarious. My party is not a party to eat at. You eat before you come. Just in case, I'll buy 1 bag of popcorn. So now if someone gets hungry, they have something to eat, and he has 3 cents left over. Again, another example. Take a few minutes, pause it, read it, discuss it. Kids do a great job. Some of them get very creative. They enjoy planning for party. I remember one student responded by using the leftover napkins and cut the napkins up to make confetti. I mean, how creative is that? Think about other questions that would get kids thinking and writing. So here's an example, gathering shells. And this comes from the book, Putting the Practices into Action. And so again, here's some information. Have the kids actually write the questions. So what questions could you ask? Pause. Talk to each other. What questions could you ask? Here's another, just information I provided. So think about your area. What kind of things do you have where people might want to visit? If you're near an aquarium, a museum, put those things out there. What questions could you ask? Think about the mathematics. And once kids write the questions, they have ownership of it and they want to solve it. Another example of writing is headline stories. In this book, they talk about headlines sum up a story. Equations are like newspaper headings, short and to the point. Equations are connected to word problems the same way headlines are connected to news stories. So using headlines can help you see students' understanding and misunderstandings. So let's take a look at an example. Solve this problem, write an equation. So in this headline story, the headline is 5 times 1.5 equals n. So kids have to write about that. What does that headline represent? So take a minute, read what the student put. What do you notice? Do they have a strong understanding of the mathematics? Obviously, they don't. How about this student? This student has an understanding of what it means to multiply using a decimal. Again, as a teacher, it helps me know what they know and understand, which will guide my instruction in the classroom. So take a few minutes, you write a headline story. Teaching and Learning in Mathematics. Another resource cited here has some great things and examples of what to use and how to use reading and writing in mathematics. Talks about rules and procedures of mathematics, makes little sense to many students. They memorize examples, they follow the rules and procedures, do homework, and take tests, but they do not understand what it means. It's great to get the answer, but what good is it if you can't explain it to anyone or apply it or understand it? Just like the example of the student who was trying to come up with a story for an equation and they had no idea what it meant. So this is why it's important to write in mathematics. So let's look at translating symbols. So if we were actually going to write these using symbols, what would it look like? If we were going to translate these symbols into words, what would it look like? Which is more challenging, to write it in words or to write it in symbols? Have a conversation with the person next to you. Which is more difficult for you? Which is more difficult for students? Should they be able to do both? Yes, they should be able to write it either way. That is the expectation of our math standards. It's digging deeper, understanding what it says and what it means. Let's talk a little bit about building vocabulary in mathematics. Learning math is like learning a new language. And this is an article, a great article, helping us better understand. For some students, it's like speaking a whole new language. Students may excel in computation, but their ability to apply their skills will suffer if they do not understand the math vocabulary used in instructions or story problems. One of the strategies used in this study for strengthening students' ability to communicate mathematically was the modified Frayer model. And some of you may have seen this before. This might be nice to include in your mathematics notebook or your math journal. Here you have vocabulary with an example and a non-example and a picture. So depending on your grade level, you may want to vary this model. Another example. It says a model used to work on new mathematical vocabulary or review past mathematical vocabulary. Teachers can check student work for understanding and identify misconceptions. And one of the quotes in the article, it says add-in means I attend school every day instead of attend school every day instead of attend school every day. See, I was even confused. So do they really know what attend or add in this case really means? This would help you know as a teacher if you really understood its meaning. A meaningful driving question motivates kindergartens to engage. In this article noted, it talks about another way to get kids, even kindergarten kids, motivated to read and write. So an example was a teacher who was writing a letter to the children, and she was asking them for input, and you can see the example, the picture there of how they went to solve and talk about that. Oral language can affect not only reading proficiency, but also math proficiency. Students making connections because of conversations among partners, including specific vocabulary. And again, a nice article to pull up, to look at and read. And this one focuses on attending to precision and what it means and what it looks like, especially with that vocabulary. This is a task that I use quite often in the classroom. And so it's building mathematic vocabulary. So pretend, since you can't see me, but I want you to estimate how much money I have. And typically I would have some in an envelope, and I would just shake it. And then have kids write down an estimation. So we're focusing on estimation skills, but also on vocabulary. I have less than $1. So kids write that down. And what they've written down, they can adjust and modify as I give them clues. But we want them to be able to justify why they made changes. I have more than $50. So we know it's less than 100, but it's more than 50. I have all dimes. So what does that mean? As kids are thinking about this, what does that mean? I have all dimes. I have more than half a dozen coins. Have somebody explain, what does that mean? What is a half a dozen? I have more than the value of 3/4. What does that mean? There's an odd digit in the amount I have. So as I refine and give more and more clues, this should help them define their answer. For some kids, they may need a hundreds board, and so as I read each clue, then I would start to mark off, or they would start to mark off. So if I said I have less than $1, we know it's less than 100. So that's definitely been excluded from my solution. I have more than 50 cents. So again, we know though all those things have been eliminated, 1 through 50. So each time, kids, I give a clue, you start to mark off until you have your final answer. So again, estimate how many pieces of paper I have. So pretend I have a bunch of paper in my hand and I hold that up and I give clues. Each time I give a clue, a student gets to eliminate possible answers until they get to the one right answer. So take a minute, pause, look at the clues, and see what you come up with. I tell you about this task because after I do it a few times, then students start writing. They use the hundreds boards because as they write, they don't want to eliminate all their possible answers, but they want to eliminate by using clues a few choices each time until they get to the final answer. And think about them having ownership of their own writing, their own thinking, their own clues, and what they decide to use. And of course, this little boy, Michael, chose to use bugs. Now let's think about another recommendation for the classroom. Establish the expectation to write regularly. We don't want them, again, to think writing is only done in writing class, that math is only done in math class. It's all intertwined. We do reading, writing, math all day, every day. Also, connect oral and written discourse. Attend to writing tasks that prompt mathematical reasoning and focus on mathematical argumentation. And this came from the article noted here. Research study on writing to learn mathematics. Very interesting. So as you can see, the teacher in this article wrote about how she was comparing her class to the control class. Her class consisted of just regular students. The other class was mostly gifted students. So you can see her test scores, the pre-test was 41 on multiplication, and the control class, which was more gifted students, was 54. The post test, 77, which was higher than the control. Same thing with geometry, which you know is built with lots of vocabulary. Her students, regular average classroom students, scored 17%. The more gifted class scored 23.5. At the post test with reading and writing about the math vocabulary, students scored 70%, where the control class, again with mostly gifted students, scored 60.3. So nice little quick study done by a teacher thinking about the importance of writing to learn mathematics. So reference that article for more about that. Here's a nice example about building vocabulary. So this is a nice sort and label. So what I did is I gave the students all these words, and then they had to sort them. So they were just in an envelope, and they had to sort them, and then they had to talk about why they sorted them in that manner and why they labeled it. And as long as kids could talk about that and they could justify their thinking of how they sorted them, then it's fine. So think about using these words and doing a word sort with your students. Sometimes you might even just pull a word, have them create what they call a word web. Again, building that vocabulary. Word mystery words, where kids would have a word and they have to give you clues about what the word was. And again, building that vocabulary. And one, I was talking to students, and again, we talk about using mathematical words. The word that one student was using was feet. And she goes, oh, I have 2 of these, and I stand on them. So we talked about, would that be an appropriate way to describe a mathematical word, feet? And we talked about a better way, if we want to use mathematical terms, might be this is a unit of measurement. It's a customary, in the customary unit of measurement, it's larger than an inch, but it's smaller than a foot. So that would be a more appropriate mathematical way to describe a word. So modeling that and letting kids have opportunity to guess mystery words. Create a number web. So here, instead of a word, we place a number there. So let's look at some examples. Number webs encourage flexibility with numbers, thinking about numbers. They have picture representation. They could actually just have the word represented in standard form, but also with expanded form, decimal form, fraction form. Again, having kids think about number webs along with word webs. A word box, another example of a way you might have children or students who will encourage them to think about the mathematics. Here's an example of what that could look like. They chose the word symmetry. They have pictures, real world examples, definitions, and an integer. Building vocabulary in mathematics. So we've talked about the importance, but there's one thing I want to caution you about. Keywords. Math is not about decoding clues, but about reasoning and making sense of situations. Flexibly thinking about the operation is essential. Van de Waal talks about in his book how keywords could be misleading. Many problems have no keywords. Keyword strategies sends a terrible message about doing mathematics. A lot of times, especially in K1, they talk about the word total means add, and there may be total that's there in K1 a lot, but when you get to 3, 4, and 5, that word total may have a different meaning, or it may not have the word total at all. And if that's the strategy that they were taught and not making sense of the situation, then what are they going to do? When I went into a classroom, I had students write some of those keywords down, and then what they did is they actually wrote some examples of using keywords when they didn't mean what they always meant. So here's an example. Nicole had 100 pieces of candy. She divided it up. So that means they divide, and gave away. So that means they subtract 10 pieces to 5 friends. What is the total? That means add pieces Nicole has now. So that means I'm going to divide, that means I'm going to subtract because I'm going to give away, and that means I'm going to add because I'm going to total. So if I've been taught that strategy, I have no idea what to do. Here's another example. Miss Kitty had 25 pencils in all. In all, it means I'm going to add. 5 students earned 2 pencils each from Miss Kitty for their great math strategy. What is the total number of pencils Miss Kitty has now? So again, I'm not really sure what I'm supposed to do. Am I supposed to add? Then I wanted to share some examples of EOG released items of keywords. It says here, Kim and Sarah sold bags of cookies. What is the total number of cookies Kim and Sarah sold? And I included the percentage of students. 60% of the students put 17 because it said total and they added, which is totally incorrect. So think about keywords. Is that really what you want to teach, or do you want to teach students to make sense of the context? And it's okay to say total sometimes means to add, but it does not always. What does it mean in this situation? Here's another example. A total amount of pizza the boys ate. What do? Do you add? Look at the percentage of students. What did they do? Another example. How many racers are there all together? What am I going to do? All together, I was told to add. So look at students. Look at what their responses are. Is this the way we want to teach students? And one more example. What is the total number of tulips in the vase? We're going to add because my teacher said we add. Look at the percentage of students who added. Almost a quarter of the students across the state of North Carolina added. Teach students to make meaning of the context. Sometimes it means add, but not always. Those mathematical problems and mathematical practices. Number 1, make sense of problems and persevere in solving them. Let's talk about speaking in mathematics. Lots of nice examples about speaking in mathematics. Here's something that you could do. It's called eliminate it. So you have to have a reason. You have to justify your thinking about why you would eliminate something. So let's look at this example. There are 4 things. Take a minute. Talk to the person beside you. What would you eliminate and why? Some people say I would eliminate join because the other 3 are typical math words. Some people say I would eliminate subtract because add, multiply, and join mean to put together. So as long as I can justify what I say, then it's fine. So here's another example. Talk with the person beside you. What would you eliminate and why? A couple of other examples. Feel free to pause, stop, think, and talk about what would you eliminate and why. This is having kids talk about the mathematics. Another great example to include in a math lesson, agree or disagree. Tell why you agree or disagree. Kids are talking about, clarifying their thinking as they do this. Here's an example of a student's response. Another example. Agree or disagree. So these are just examples that you could have some conversation about and use in your classroom. Take a few minutes, choose one, and talk about, do you agree or disagree and why? Justify your thinking. Reading in mathematics. Again, let's refer back to the North Carolina reading standards. They are expected to read in content areas. They have to be able to understand what it looks like, what it means, so that they can solve problems. This is one of my favorite books, and you can click on the YouTube part at the bottom of the link, and it'll take you to someone reading it if you don't have the book. If you don't have the book, I would strongly encourage getting the book. It's just one of my favorites. And when people read it, they think about the story. They don't think about mathematics. So there was this pig. It was a pink, pushy, plump pig who always wanted to be first. So if you were to use 2 adjectives to describe you, what 2 adjectives would you use? This is Pinkerton, the one in the middle, and he's referred to as a pink, plump, pushy pig. So how would you describe yourself? So when you're thinking about the rich vocabulary, the rich reading there, you're not really thinking about mathematics. But how about now? Pinkerton and his 4 pink plump friends were getting ready for a trip when one fell down. How many pigs were left standing? Does this look just like an EOG question? Definitely. So, and it's a nice visual. Kids can relate to Pinkerton because a lot of times some of the kids act like Pinkerton, pushing, wanting to be first. So kids typically, again, they see 4 and they see 1, so they're going to say 4 minus 1. But if they made sense of the problem, which is Pinkerton and his 4, that's 5 pigs and 1 fell down. How many were left standing? So they're building the vocabulary, they're reading, and they're thinking about what it's saying, and they're also thinking mathematically. So thinking about mathematically, let's look at Pinkerton as he goes to the cafeteria. So he's in line first in the school cafeteria. There are 14 pigs in line behind Pinkerton in the school cafeteria. How many pigs are there in all? What ordinal number would be the center pig? So you might have to role play. Again, me first, me first. Pinkerton's wanting to be first, and we can think mathematically. As he goes on the bus, he yells me first. Pinkerton's bus left at 9:05. Let's think mathematically. Arrived at 10:15. How long did it take Pinkerton to get to the beach? How long would they spend in total on the bus for the field trip? Lapse time. But it's about Pinkerton. Kids want to solve it. They're excited. So think about how you can use books just like this and write about mathematics. Here's some reasons why we use children's literature. Again, it fosters development of number sense. It integrates math in other areas. It's meaningful. Again, making meaning of the context, seeing how math relates to reading. Learning and assessing mathematics through reading. This was a nice research article, and it talks about reading and writing about math is not the same as reading and writing in math. Students who have opportunity, encouragement, and support for purposeful writing and reading in mathematics classes will have a more concrete grasp of concepts and be able to apply learning to alternate situations. And I have found that to be true. Here's some more research. And I don't want to read all of this to you, but know that this is here. Feel free to pause and read. But it does talk, it shares really makes you think about the importance of mathematics in the text. And how is it different? How is it like the text that we see day to day? Feel free to pause and read more. This article talks about students and what students believe about math and what good math is and what students believe what good math problems are. There are good math problems. It's interesting and it's challenging. And it's about the everyday world. It's not something that's irrelevant to what they're doing. Learning mathematics, it says, in reality, no one can teach mathematics. Effective teachers are those who stimulate students to learn mathematics. Educational research offers compelling evidence that students learn mathematics well only when they construct their own mathematical understanding. They need to make sense of it. What questions do you have? Talk with your neighbor. Think about this. Look at the research. What do you want to know, and how do you go about making a difference in your classroom? Again, my name is Kitty Rutherford. If you have any questions, feel free to email me. And I appreciate you taking the time to learn what the research says and other strategies and tools that you can use to enhance students with mathematics. Thank you for all you do for North Carolina students every day. Have a great day.